Hi guys, this is the Academic Chemistry 3.2 video, the International System of Units. You're going to need a few things for this video. So obviously you need your follow along notes to fill in as we go through material, but you also need this handout. It's the 3.2 handout. So it has your metric system prefixes and then metric system units. So this up and down, nope, these are the prefixes and these are the units that you need to know. We're going to go over how to use that later. You also will need a calculator. Okay, so what is the International System of Units? It's basically a fancier metric system. So there are some differences between the metric system that like your parents may have learned when they were in chemistry and the International System of Units now, but you don't really need to know those differences, just know that they're somewhat interchangeable. And what this is a universal way to describe measurements. So it's not very helpful if you say like, oh, I went to the lab and I found the answer was 8. And people be like, well, 8 what? Like you need a certain way to measure it. Like, is it 8 grams? Is it 8 liters? 8 meters? The other thing is it needs to be universal from us to other parts of the world. So in America, we use some really weird measurements. Like we use feet, which no one else uses. Those 12 inches. Awful. If you put feet or inches on a paper and you turn it into me, not good. So it's always meters. And Americans are kind of at a disadvantage if you're an American student learning this because you haven't used meters your whole life. Like if you go over to Europe and you see on the side of the road a speed limit, it doesn't say miles per hour. It's actually going to say kilometers per hour because they measure things in kilometers, which is a kilometer. So speaking of that, let's first talk about length. So length is a linear thing. So length is the distance between 2 points. So if you literally have a point and another point, that straight line that connects them. So you could figure out like the length of an object of this calculator would be from here to here. You use a ruler to figure this out, or a meter stick because the unit is the meters. If you're using a ruler though, like I said before, no inches, make sure you use centimeters. So those are the small ones here. If you forget which one, a centimeter is about the width of your fingertip or your pinky finger. So that's the one to identify. And that's meters is the base unit. It can be centimeters, kilometers, picometers, and we'll go over those prefixes later in the lesson. The next thing is volume. So volume describes how much space an object occupies. So for example, I have this ball and I have this ball. And the biggest difference between these two is the size. See how this one's really small, this one's really big. These balls are actually about the same size if you put them on a scale, like they have the same mass, but the actual volume or space that it occupies, if you look at it, this one occupies less space than this one. The unit is typically liters because we're going to use a lot of fluids. But it could also be centimeters cubed. So in your math class, you probably did length times width times height before. And that's when you're dealing with something that is very cubical, like this. So if you're trying to find the length and the width and the height, you're going to use a ruler. And you put it next there, find one, then find the other, and then back and forth, and you multiply them by one another. Since you have centimeters times centimeters times centimeters, then that's why it's centimeters cubed. Now one thing to know is that 1 milliliter is equal to 1 cubic centimeter. So let's say I have a liquid that's in this graduated cylinder and it has the volume of 1 milliliter. If I were to pour that liquid into this cube, there was an opening, and this cube is 1 centimeter by 1 centimeter by 1 centimeter, so 1 cubic centimeter, because 1 times 1 times 1 is still 1. Then this would perfectly fill this cube with no extra and no leftover, because 1 milliliter also always occupies 1 cubic centimeter. The next unit we want to talk about is mass. So mass is the measurement of how much stuff is actually in an object. So it has nothing to do with how much space something takes up. You might think of like when you stand on a scale. So a scale tells you the mass. You could, if you put a box on a scale and then you put a whole bunch of stuff in that box, then the mass goes up even though the amount of space that it occupies doesn't change. Kilograms is the base unit. So mass is the only one that has a base unit with a prefix in front of it. So a lot of people think that grams is the base unit, but grams are really, really, really small. And the base units are typically things that we deal with in everyday life. So if I wanted to find the mass of my whole body, grams would be really way too small. Kilograms is a more accurate representation. A lot of kids also confuse weight with mass. So weight is the force caused by gravity on mass. So the more mass you have, the greater the force that the Earth pulls on you, or whatever large body it is, like maybe it's the moon or Jupiter, or whatever it happens to be that you're standing on, or whatever that object is. But weight equals mass times gravity. So for example, the moon has about 1/6 of the gravitational pull that Earth has. So whatever your mass is, gravity only pulls 1/6 on the moon, so it is an instant way to lose weight is by going to the moon. Your weight would be 1/6 what it is on Earth. The next thing is density. So density we're going to cover later in Chapter 3, Section 4 in a lot more detail, but basically it's how much stuff is stored within a specific area. So remember we had that box before, and it had a certain mass and a certain volume. So an empty box sitting on a scale, you can see how much the mass is, and it has a specific area. As soon as you stuff more things inside the box, the density goes up. The mass goes up, but the volume stays the same. Typically, this is going to be in grams per milliliter, or if it's a larger scale, it's going to be kilograms per liter. All of the things we're learning about today are called quantitative measurements. So measurements that have quantitative values or data, they tell you numbers about that object. So here's a tennis ball. If I were to describe this just by looking at it, I might say, oh, it's yellow. But that's not a quantitative measurement. Quantitative measurement might be 58 grams. Or the fact that it's 131 cubic centimeters, which, as we know, also occupies the same as 131 milliliters, because centimeters and milliliters are the same. In the metric system, our prefixes go in front of units to change it by the factor of 10. And you might say, why 10? And because 10's easy. Our number system is based on tens, which is you just move the decimal around. So if you ever notice when you divide by 10, you just move the decimal once to the left. Or if you multiply by 10, you just move the decimal once to the right. So changing by a factor of 10 is really, really easy once you get used to it. And you might ask why our number system is based on 10. It's because 10 makes sense because we have 10 digits. So let's say you have a meter stick, for example. This right here is 1 meter. Now I know it's really fuzzy, but just pretend that it's right there in front of you. And my question is, in this meter stick, how many centimeters? So if you have a meter stick at home, go ahead and get it, but otherwise you're just going to have to believe me. If you were to count the centimeters on a meter stick, you would find that there are 100 centimeters. So 1 meter and 100 centimeters is the same thing. You could also look at the millimeters. Now the millimeters are those teeny, 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 tiny ticks within each centimeter. And there are 9 ticks, or saying there are 10 millimeters in every 1 centimeter. So there's 1,000 millimeters in 1 meter. And why does this? So that all makes sense because centi, as you remember, means 10 to the negative 2, which you know that if you know what like a century is. It divides into 100 pieces. So the negative here means divide, and 10 to the 2 is 10 times 10, which is 100. You also have all this here on your prefixes. So on here, if you find centi, it's equal to 10 to the negative 2. So you know that it's divided by 100 pieces. Milli is 10 to the negative 3, so it's divided by 1,000. So here's the rule. When you want to write a measurement of equal size, but you want to get rid of the prefix, you're going to replace the prefix with the base 10 and multiply it by the number in the measurement. So if you're removing a prefix, you have to replace it with a base 10. And that comes from this. Okay, so get your chart out and get out your calculator too. All right. How many grams do you have in 67 kilograms? So kilo is the prefix. So you're going to look on your chart and see what kilo is. Kilo is 10 to the third. So you want to replace kilo with 10 to the third. You take the number you have, multiply it by 10 to the third grams. So 67 times 10 to the third grams. These two measurements are equal. I could say 67 kilograms, or I could say 67 times 10 to the third. 10 to the third is 1,000, so it's 10 times 10 times 10. So this is technically 67,000 grams. I get that in my calculator. Now, I prefer things in scientific notation. So scientific notation, the decimal is here. It needs to be after the furthest unit to the left. So it needs to be right there. So this is going to be 6.7 times 10 to the 4th grams. Okay, let's do another one. My next question is how many liters are in 5 picoliters? So I want just liters. I've got picoliters. So I need to remove the pico and replace it with a power of 10. So I look on my chart, and my chart says that pico is actually 10 to the negative 12. So 10 to the negative 12. So I rewrite it as 5 times 10 to the negative 12 liters. Because my coefficient, or this number up front, is between 1 and 10, I don't have to change it at all. It's already in scientific notation, so I'm done. There's your answer. Let's do one more. How many liters are in 35 cubic centimeters? So we've got cubic centimeters and we want liters, which is weird because there's no prefix to get rid of. But if you remember, 1 milliliter equals 1 cubic centimeter. So however many cubic centimeters I have, I can change that to liters. So I'm going to make this into 35 milliliters. From here, I can easily convert it because I can remove milli and replace it with its 10 power. So I look on my chart and I find milli. Notice milli has a lowercase m. Don't confuse milli and meters. Milli is always going to go up front. So if you see a lowercase m by itself, it's meters, but if you see it in front of something else, it's milli. That's one of the weird ones. Okay, I found milli, and it's 10 to the negative 3. So this equals 35 times 10 to the negative 3 liters. This won't work because my number in front is greater than 10. So I can only have one digit to the left of my decimal. So here's my decimal. So the way I work this out is 35 is the same as 3.5 times 10 to the first. This is my 35. So that's this part. I still have my 10 to the negative 3, and I still have liters. When you have two numbers that are multiplied by each other with the same base and raised to exponents, you can add up those exponents. So since I've got 10 to the first and 10 to the negative third, so my 3.5 doesn't change, it's times 10 to the first and 1 plus negative 3, 10 to the negative 2 liters. The other thing you can do with this is you could have plugged it into the calculator. So I'm going to show you how to plug it into the calculator using scientific notation. Now, it won't always give you scientific notation unless you tell it to. So let's zoom out so you can see what I do. So I did 35 times 10 to the negative 3. So 35 times 10 to the negative 3 equals. So that gives me that, which is not scientific notation. But if you press second, that gets you to functions above the buttons, and above this degree button, it says scientific or engineering. If you can see that, it's kind of blurry. So I'm going to click that, and I'm going to change it to scientific notation, press enter, and notice it gave me 3.5 times 10 to the negative second, which is my answer down here. And don't forget about your units. So that's it for today's lesson, and make sure you talk to me or one of the other chem teachers if you have any questions. Okay, good luck.